working on the answer key to our review sheet here. Remember, feel free to skip through the video as you need. Write the following number in scientific notation. So I'm going to box where my significand would be. So I know it's going to be 1.02 times 10 to the, it's a big number, so positive exponent. Now counting my decimal places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 times 10 to the 11th. Do the same thing here. Here's my significand. Decimal point there, so 2.3 times 10 to the, it's a small number, so I know it's going to be a negative exponent. Let's count it. 1, 2, 3, 4, 5, 6, 7. 2.3 times 10 to the negative 7th. Box my significand, put my decimal, 9.807, big number, positive exponent, and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. Oh, significand, there it is. It's going to be right there. 5 times 10 to the negative, because it's a small number. 1, 2, 3, 4, 5. 5 times 10 to the negative 5th. Now on number 2, we're going the other way. We are going to write our answers in scientific notation into standard form. So I always like to rewrite, and then times 10 to the 8th, we're going to move it 8 spaces, big number, 1, 2, 3, 4, 5, 6, 7, 8, new decimal point, and we fill with zeros. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, okay. Okay, there we go. See, I had to count it a bunch of times just to make sure. Okay, 1.23 times 10 to the negative 4. Negative, it's going to be small, so we move 4 spaces to the left. So we go 1, 2, 3, 4. So 0.000123. Okay, 6.7 times 10 to the third big number, 1, 2, 3. So we get 6,700. Notice how I'm rewriting my answer so I'm not showing the swoops of my decimal place in my final answer. 6, decimal point is there, negative small number. So 1, 2, 3, 4, 5. 0. There we go. Boom. On number 3, we're going to compare. First thing I'm looking at is powers of 10. 10 to the 5th is bigger than 10 to the 4th, so that's bigger. 7th to the 7th, ooh. So now I have to look at my significands. 4.7 is larger than 3.9. So 3.9 is less, 3.9 times 10 to the 7th is less than 4.7 times 10 to the 7th. On C, I've got to either write in standard form or scientific to figure it out. Let's see, there would be my new decimal point. Let's see, 1, 2, 3, 4, 5, 6. So that would be 7 times 10 to the negative 6th. So that is less than 7 times 10 to the negative 5th. On D, look at that. That's a negative. That's guaranteed to be smaller, right, than anything that would be positive. Okay. E, 95.9 times 10 to the 0, right? That's just going to be 95.9. 7.63 times 10 squared, that's going to be 763. Okay. And then here, 8.065 times 10 to the negative 6. Let's see. That's where our decimal would be. 1, 2, 3, 4, 5, 6. So they're going to be equal. That would also be 8.6065 times 10 to the negative 6th. On 4, where we're ordering from least to greatest, I'm going to kind of be a little strategic here. I see that negative, I automatically know that one's my smallest, guaranteed, because it's negative. It's farthest left on the number line. Now I'm looking at our powers of 10 for our smallest, so our most negative exponent. So we've got 10 to the negative 6, 10 to the negative 6. So we're looking at our significands. 4.056 is smaller than 4.506. Okay, so that'll be second and then third. 2.14 times 10 to the 0, that's just going to be 2.14. So that's probably our biggest. Yep, negative exponent. And there we go. And remember, rewrite how the numbers were given to you. And there's our answer. On page 2, we're going to get into our operations. Multiplication, let's regroup our significans. And then we got our powers of 10. We can kind of skip ahead, remember, and keep the base, add our exponents when multiplying with same bases. 4.5 times 1.2 gives us 5.4 times 10 to the 8th. And we check, is that in proper scientific notation form? It is, so we're done. On this one, let's see, 4.25 times 2.1 times, let's see, 10 to the negative third, 10 to, that's going to be negative 3 plus negative 6. So let's see, 4.25 times 2.1, 8.925 times 10, negative 3 plus negative 6 is going to be negative 9. Is that in proper scientific notation form? It is, so we box it. So now we're getting to our division. When we do division, I'm going to stack it like a fraction. Just helps me with organization. Okay, so I'll leave the significans showing the division. And then remember, dividing with same bases, we're going to subtract our exponent. So that's going to be negative 4 minus negative 3. So notice we have that double sign, same sign sum, making that negative 4 plus 3. So I grab my calculator and we're going to do 9.43 divided by 2.3 to get 4.1. So that's going to be 4.1 times 10 to the, let's see, negative 4 plus 3 is negative 1. And that's also in perfect scientific notation form, so we can box it. Okay, we always want to be checking, is that proper scientific notation form, or do we need to adjust it? Okay, and then we've got 8.1 times 10 to the second divided by 2.5 times 10 to the 6th. So let's see, that's going to be 2 minus 6 for our powers of 10. 8.1 divided by 2.5, 3.24 times 10 to the negative 4th, and also in perfect scientific notation form. Okay. On number 6 and 7, we're getting into our word problem. So we want to decide, is it multiplication or is it division? A single speck of dust weighs about 1 times 10 to the negative 6 grams. How much do 2.4 times 10 to the 8 specks of dust weigh? Write your answer in scientific notation. Okay, so this one is going to be a multiply problem, right? Because that's how much one speck weighs. And then we've got that many specks. So it's going to be, let's see, 1 times 10 to the negative 6 times 2.4 times 10 to the 8th. Put our significans together, but it's times 1. So, and then 10 to the negative 6 plus 8. So that's going to be 2.4 times 10 to the second, and our label, grams. It said write in scientific notation, so that's how I'm going to leave it. On the test, it's going to say write in scientific notation and in standard form. Now, number 7. Company has 2 times 10 to the 4th employees. If the company pays out 6.4 times 10 to the 8th dollars and each employee makes the same amount of money, then how much money does each employee get paid? Okay, that many employees, each make that. How much do they all get paid? How much money is paid out? That's going to be another multiply problem. Okay. So we're going to be doing 2 times 10 to the 4th times 6.4 times 10 to the 8th. Okay, so we'll separate them. 2 times 6.4. Add our exponents there. Okay, 12.8 times 10 to the 12th. And we're talking money, so that's going to be dollars, leaving scientific notation. So there we are. On page 3, more word problems. Mary solved the following problem. 5.3 times 10 to the negative third times 6.8 times 10 to the negative 10th in scientific notation. She says the answer is 3.604 times 10 to the negative 14th. Is Mary correct? If she is incorrect, then correct the error. Well, we don't see her work, so I can't tell what the error is, so I'm going to have to do it myself to see if she is correct or not. So let's see. 5.3 times 6.8 times 10 to the negative 10th. So put our significans. Powers of 10, remember, keep the base, add the exponents. So let's say 5.3 times 6.8 is 36.04 times 10 to the negative 3 plus negative 10 is negative 13. Not in proper scientific notation form. That is too big. Big numbers, positive exponents. So we're going to have to add to the exponent, positive plus, and we move one space to make it 3.604. So since we move one space, we're going to add 1. Negative 13 plus 1 is negative 12. So Mary is not correct. Mary is not correct. Okay. If she is incorrect, then correct her error. Well, my guess is that Mary subtracted an exponent of 1, subtracted 1 from the exponent instead of adding. So that's what I'm going to say. I'm going to say Mary subtracted 1 from the exponent instead of adding. That was good. I like that problem. Okay. So 9. This one's kind of fun. The Apple Macintosh computer released in 1984 came standard with 128,000 bytes of memory. The lowest amount of memory on the iPhone 11 Pro is 64 gigabytes. If 1 gigabyte is equal to 1 times 10 to the 9th bytes, about how many times greater is the memory capacity in the iPhone 11 than the 1984 computer? So remember that how many times greater, that means we're going to divide. But there's a little issue here. That 128,000, that's not in scientific notation. So I'm going to just adjust that to scientific notation. So that's going to be 1.28 times 10 to the, let's see, 1, 2, 3, 4, 5. So I'm just going to do my notes here for my 1984 computer. That's 1.28 times 10 to the 5th bytes. Okay. And the iPhone 11 Pro has 64 gigabytes, and 1 gigabyte is equal to 1 times 10 to the 9th. So we want to get into the same unit. So I'm going to say let's do everything in bytes instead of gigabytes. So let's see the iPhone, right? If it's 64 gigabytes, and I want to know how many bytes, it would be 64 times 1 times 10 to the 9th. So that's going to be 64 times 10 to the 9th bytes. And if we want, we can put that into proper scientific notation for 6.4 times, and that was too big, so we add 1, 10 to the 10th bytes. And now we have to divide. So how many times greater? That's going to be iPhone divided by the computer. So 6.4 times 10 to the 10th divided by 1.28 times 10 to the 5th. So I'll structure that as a fraction for myself. Keep the base, subtract the exponents. So let's say I'm just going to flow my work over here. 6.4 divided by 1.28 is 5 times 10 to the 5th. So that's 5 times 10 to the 5th times as great. And I'm going to say, let's put that into standard form. So that would be, let's see, decimal points there. It's going to be bigger. So there'd be 5 zeros. 1, 2, 3, 4, 5. So that's 500,000 times as great. So that iPhone 11 you can fit in your pocket has 500,000 times as much memory as a computer that came out in 1984. Amazing. Okay. So then number 10, the approximate surface area of Earth that is covered by land is 1.49 times 10 to the 8th kilometers squared, and 3.68 times 10 to the 8th kilometers squared of the Earth's surface is covered by water. Approximately how many times greater is the amount of Earth's surface that is covered by water compared to the amount of the Earth's surface that is covered by land? So water to land. So we're going to do water divided by land. So that's going to be 3.68 times 10 to the 8th divided by 1.49 times 10 to the 8th. So really what I'm seeing is this is really going to be more of a significance problem, because those powers of 10 are going to cancel out. So that's going to be 3.68 divided by 1.49. which will give us, ooh, look at that. Okay, so when we get 3.68 divided by 1.49, right, we do 10 to the 8th minus 8, which is going to give us a 0, right? This 3.68 divided by 1.49 gives us a really long decimal, 2.469798658, really long. So I'm going to say, let's kind of look at what our numbers are doing here. The numbers in our example, they have 3 digits in our significand. So I'm going to suggest let's round to those 3 digits and make it 2.47. So we'll say it's 2.47 times 10 to the 0, which is 1. So 2.47 times as great. So just a little less than 2.5. Okay. On 11, the mass of the moon is about 7.3 times 10 to the 22nd kilograms. It would take approximately 26,000 moons to equal the mass of the sun. Determine the mass of the sun. So this is going to be a multiply problem. But again, a little issue here that this isn't in scientific notation. Let's see, we've got 1, 2, 3, 4, 5, 6, 7. So that's times 10 to the 7th. So we're going to do 7.3 times 10 to the 22nd times 2.6 times 10 to the 7th, right? Significans. Keep the base, add the exponent. So that's 18.98 times 10 to the 29th. Well, definitely not putting this in standard form, but we want to notice that that's not proper scientific notation. That's too big, right? Too big. Positive exponents have to add to the exponent. We're going to add 1. So 1.898 times 10 to the 30 kilograms. Woo! That's a big star.